Hello students, welcome back to Rasayan. In last video, we studied about reaction intermediates carbocation and carbanion. Let's start free radicals. Now see, between two atoms A and B, there is one covalent bond. If A and B are having higher electronegativity difference, then by heterolytic bond cleavage, carbocation and carbanion will generate. But if A and B are having comparable electronegativity, then what will happen? The bond will cleave by homolytic cleavage. So, homolysis will take place and we will get free radicals. So, it is written homolytic cleavage gives free radicals. Now, see, examples of free radicals are this one. It is called chlorine free radical. This is methyl group CH3. So, methyl free radical. Now see, in these free radicals, consider this one. Here, after sharing, how many electrons are there in the valence shell of carbon? After sharing, it is having 1, 2, 3, 4, 5, 6, 7. 7 electrons means it is having odd electrons. Here also, it is having 7 electrons in its valence shell. Now see, if you consider only carbon atom in its valence shell generally it is having 2s2 2p2 means 4 electrons. Here also after sharing don't consider, only consider carbon atom. 4 electrons are there. So it is electrically neutral species. No gain, no loss. Okay. So it is written homolytic cleavage results in the formation of neutral species. It may be atom or maybe group. This is group methyl group which contains an unpaired electron. It is having one unpaired electron because that shared pair of electron, how it is divided, one is gaining by B, another is gaining by A. These species are called free radicals. Next point, it is odd electron species because we have seen after bonding, here it is having, after sharing it is having 1, 2, 3, 4, 5, 6, 7 electrons in its valence shell. And here also it is having 7 electrons. It has incomplete octet because octet means at the valence shell 8 electrons should be there. So it is incomplete, 7 electrons are there. So it is electron deficient. We can write it can act as electrophile means electron loving species since it is electron deficient. Next point, hybridization of the carbon is sp2 here. sp2. In the valence shell of carbon, it is having 4 electrons. So, hybridization is sp2 means 3 sp2 orbitals, 1 electron each is combining with 1s orbital of hydrogen to form 3 sigma bonds. There is one p orbital perpendicular to the plane having the odd electron. This is unhybridized p orbital. Its geometry is trigonal planar. Actually, to predict the structure of any species, we have to consider bond pair and lone pair, both. But here it is having one odd electron. This species is odd electron species. So, structure of the free radical is very difficult to predict. But for methyl, ethyl means alkyl free radical, structure is trigonal planar, it is observed. Structure of trifluoromethyl free radical is pyramidal. It is pyramidal. Actually, what is happening, if you replace this hydrogen by fluorine, what will happen? Fluorine is having lone pair of electrons. So there will be repulsion between this lone pair and this odd electron. Here also lone pair and odd electron. Here also lone pair and odd electron. Due to this repulsion, there will be little bending of these CF bonds. So we will get here pyramidal structure. Due to presence of odd electron, free radicals are paramagnetic in nature. Now see condition for the generation of free radicals. In presence of heat or light or electricity, or in presence of peroxide, or in presence of another free radical, free radicals are generated. Generation method number 1. In chlorine molecule, there is no electronegativity difference between the atoms. So in presence of heat or UV light, symbol is H nu. What will happen? Homolysis will take place. You will get chlorine free radicals. Now see, free radicals can be formed in a number of ways. 2 ways I am showing here. If you are having one free radical, if you are treating with this alkane, methane, in presence of heat or light, UV light, what will happen? Between carbon and hydrogen, electronegativity difference is very, very low. So what will happen? Homolysis will take place. This bond will cleave like this way by homolytic cleavage. So here it will form H dot. H dot and Br dot will form H Br. And here you will get methyl free radical. These are of 3 types. Primary examples are methyl, ethyl or N-propyl free radicals. Carbon is having odd electron is there. It is having at least 2 hydrogens for primary. For secondary, where odd electron is there, at least there will be 1 hydrogen only. So isopropyl free radical is secondary. And if the carbon where odd electron is there, no hydrogen atom is present, this is tertiary free radical. Example is T-butyl free radical. Since free radicals are very, very short-lived, they are highly unstable, so they are reaction intermediates. Ward's reaction, Kolbe's electrolysis, anti-Markovnikov addition, all those reactions are taking place via free radical. Next reaction intermediate is carbenes. These are short-lived and highly unstable. Now see, we have studied about carbocation, carbon ion free radicals. These are very common reaction intermediates, but carbenes are comparatively less common reaction intermediate. Now see, in carbene, carbon is covalently bonded to monovalent atoms or groups and has 2 non-bonding electrons. Now see, we are writing here non-bonding electrons, not we are writing lone pair. Why? I will tell you later. Examples of carbenes, if here hydrogens are there, it is methylene carbene. If 2 Cl atoms are there, it is dichlorocarbene. Now see, this is electrically neutral species. Why it is electrically neutral species? Carbon is having atomic number 6. It is having electronic configuration 1s2, 2s2, 2p2. So in valence shell, it is having 4 electrons. Here only for carbon atom you see it is having 1, 2, 3, 4 electrons at the valence shell. So no loss, no gain. That's why it is neutral. Now you see in carbocation it is having 1 unit positive charge. This is methyl carbocation. Carbocation I am writing here. Carbocation. Now see what's the difference. Here after sharing it is having 1, 2, 3, 4, 5, 6 electron, but it is neutral species. Here also after sharing it is having 6 electrons at the valence shell, but here it is having positive charge. Why? Because see at the valence shell of carbon only you consider, not after sharing, you consider only carbon atom. It is having 1, 2, 3, 4 electrons. But here at the valence shell it is having 1, 2, 3 electrons. So 1 electron less than this. That's why 1 unit positive charge. Now see in the carbene, it is having 1, 2, 3, 4, 5, 6 electrons in the valence shell after sharing. So it is having incomplete octet. So it is electron deficient. Electron deficient species means it is acting as electrophiles, means electron loving species. Now see dimer-diamine reactions and carbylamine reactions. In those reactions you can see carbenes as reaction intermediates. Means these reactions takes place via carbene reaction intermediates. Carbenes are of two types. One is singlet carbene, another is triplet carbene. I will explain little bit each type of carbene. Now see in singlet carbene, carbon atom is sp2 hybridized. Valence shell electronic configuration of ground state of carbon atom is this one, 2s 2p. Okay. Now for singlet carbene, since it is sp2 hybridized, so this is sp2, these three are sp2 hybridized orbital and this is vacant p orbital. Here two electrons are in the same orbital with opposite spin. Here one electron, here one electron. Now see, two of the three hybridized orbitals, these two hybridized orbitals are utilized to form two covalent bond, and third orbital containing a pair of electron. Here for singlet carbene, the third orbital contains a pair of electrons with opposite spins and it is there sp2 hybridized, and there is one vacant 2p orbital which is unhybridized. So this is vacant p orbital. These three are in one plane and this is perpendicular to the plane. We know for sp2 hybridization geometry should be trigonal planar if three sigma bonds are there. But here one lone pair of electron is there. Shape of the molecule is just, you covered this one, it is V-shaped. Shape of the molecule is, shape is bent, or you can say V-shaped. So there will be bond pair lone pair repulsion from both the side. So this bond will no longer be 120 degree, and it is observed that for singlet methylene carbene, we can show this one like this. Since it is present as lone pair, means two electrons are there in the same orbital with opposite spins. So here this bond angle, it is observed, it is around 103 degree due to bond pair lone pair repulsion. And see here no unpaired electrons are present, so it is diamagnetic. Why it is singlet carbene? Spin multiplicity is equal to, spin multiplicity is equal to 2 into S plus 1. S means total spin. So here one is plus half, another is minus half, plus 1. So we are getting 1. This means it is singlet. Spin multiplicity is 1, that's why it is singlet carbene. Let's start triplet carbene. Two types of triplet carbenes are there. One is sp2 hybridized triplet carbene, means here hybridization of carbon is sp2. Another is sp hybridized triplet carbene, means here hybridization of carbon is sp. Spectroscopic data showed that the triplet methylene carbene is bend shaped with bond angle 136 degree. How will you explain this one? Now see here carbon is sp2 hybridized. Two of the three sp2 hybridized orbital are utilized to form two covalent bonds. And the two non-bonding electrons have parallel spins, and both the sp2 and p orbitals contain one electron each. So here unpaired electrons show properties of diradicals. And here for methylene carbene, these two electrons we can show like this way, and for methylene carbene this bond angle is 136 degree. And for triplet state of other carbenes, some other carbenes, they are having bond angle ranging from 130 to 150 degree. These are also bend shaped. Now see here, what is the spin multiplicity? Spin multiplicity, you know already, this is 2s plus 1. This is total spin. Mod is there. So if both are having plus halves, multiplicity you are getting 3. If both are having minus half, so minus half means minus 1. So you are getting, since mod is there, you are getting 1, and then 2 plus 1 is equal to 3. Okay, so here spins will be parallel. For sp hybridized triplet carbene, carbon is in sp hybridization. Two sp hybridized orbitals are utilized to form two covalent bonds, and here two non-bonded electrons will go one into each p orbitals with parallel spin according to Hund's rule. Because these two p orbitals are having same energy, these are degenerate. This type of carbenes are having linear structure. Since sp hybridized, so linear shape. So we have seen for triplet carbene, if it is sp2 hybridized or if it is sp hybridized, here unpaired electrons show properties of diradicals. So these are paramagnetic. So here for methylene carbene, singlet you can show like this. This is singlet. For all other carbenes which are existing in singlet state, you can show like this way, the unpaired electron, and if it is in triplet state, you can also show like this way. Here it is lone pair, but here it is diradical in nature. Or singlet you can show in this way also, CH2, both electrons are having this spin, and for triplet electrons are having this spin, means parallel spin. This one. Okay, so either this or this, any way you can represent. Generally for reaction mechanism, when we are writing, we are showing this way only, carbenes. Now we will see stability of singlet and triplet carbene. Now see, all carbenes have the potential to exist in either the singlet or the triplet state. If we say that methylene is triplet carbene, that means that triplet is more stable. And when we say dichlorocarbene, means CCl2, this one, this is singlet carbene. That means the singlet, this species, is more stable than triplet. Now see, for methylene carbene, triplet carbene is more stable than singlet carbene. What's the reason? Due to spin pairing, energy of singlet carbene should be released, system should be stable. That energy is not enough to overcome the electrostatic repulsion that exists between the two electrons in the same orbital here. But for triplet carbenes, two electrons are in different orbitals, so there is less electrostatic repulsion here. For singlet carbene, due to spin pairing, energy of the system is released. Yes, since spin pairing is there, so energy of the system is released and system will be stabilized, should be stabilized. But that energy is not enough to overcome the electrostatic repulsion between the two electrons in the same orbital. But for triplet carbene, two electrons are in different orbitals, so electrostatic repulsion for that is very less. That's why triplet methylene carbene is more stable than singlet methylene carbene. For dichlorocarbene, singlet state is more stable than triplet state, because here chlorine is having lone pair of electrons, and the p atomic orbital of chlorine with lone pair of electrons can overlap laterally with empty p atomic orbital of singlet carbene. Stabilization, or you can say delocalization of electrons are possible here. That's why singlet carbene is more stable, because in triplet carbene no vacant p orbital is there, so that type of delocalization of the lone pair of electrons of halogens are not possible here. That's why in this case singlet is more stable due to delocalization of these electrons in the vacant p orbital. Next reaction intermediate is nitrene. In short only I will tell about it. This is alkyl nitrene, this is phenyl nitrene. These are reaction intermediate, these are neutral in nature. It can also exist as singlet and triplet state. See, singlet state like lone pair here, and here it is like diradical. These are electron deficient species, so these are highly reactive. Why electron deficient species? In valence shell of nitrogen, after sharing, how many electrons are there? 1, 2, 3, 4, 5, 6, less than octet. So these are electron deficient species. That's all for reaction intermediates. Thank you for watching.